Hi, everyone. My name is Radha, and I'm a staff and software engineer in cloud networking team at Slack. We look after all of Slack's ingress load balancing tier, DNS, CDN, and so on and so forth. Unless you all decide otherwise, this is what next 30 to 35 minutes of your lives look like. I'm going to talk about why we did a thing that we did, what is user-aware traffic management, what the architecture looks like, what we got out of it, and why we think it's worth talking about in front of you all. For those who need a refresher, Slack is a team communication platform for workplace. You can chat with your team members in real time, share code, or whatever it is that you do at work. Slack offers a wide variety of API comprising hundreds of HTTP methods with millions of network requests at the edge every single day. Nearly everything that you do in Slack, from sending a message to switching a channel to looking up for a team member, is one or more API requests under the hood. It's the heart of how Slack works. A couple of years ago, we had a number of incidents that negatively affected parts of our infrastructure. During each of those events, we received a large number of API calls that overwhelmed our application monolith, affecting majority of Slack users. Currently, the authentication process lives in the application layer and has been since Big Bang, which is further down the ingress load balancers, and hence the authentication information is unavailable at the edge. Because of that, we didn't have any way to block or rate limit requests either manually or automatically based on user characteristics. In addition to that, our existing rate limits only apply to the requests that are authenticated, and in many cases, they were not even enough. This gap in validation at the ingress level exposes our APIs, especially the resource-extensive one, to potential abuse. So, what is user-aware traffic management? We were not very creative with the name, sadly. We could have gone for, I don't know, yellow panda or pink fluffy unicorn, but we kept it simple. It does what it says. It enables us to do traffic management based on user characteristics. And the user here is very Slack specific, and it doesn't have to be, but it works better for us. For those wondering, Team ID is a machine-generated ID that represents a Slack workspace. For example, some of you may be familiar, USENIX SREcon is a workspace name, human-readable, but underneath it has a machine-generated ID. Likewise, user ID is a machine-generated ID for a user in a workspace or a team. Team ID is used interchangeably for both a team and a workspace. It's a bit overloaded, but I call it tech debt. The only reason we picked this is because this represents a workspace or a user in a workspace much more reliably than anything else for us. So, bringing it back to what is user-aware traffic management, this is a system that solves some of the problems that I was just talking about in the previous slide. It does rudimentary authentication at the edge, extracts user information. You can see the example there. It extracts user information from the request and sends it back to the load balancer as response headers. The information that it sends back to the load balancers is used to make routing decisions. based on user identity. This could be either user ID or team ID. I mean, there are other things that we send, but for the purposes of this talk, I'm just going to focus on team ID and user ID. Okay, so let's look at the architecture. Before diving into the architecture, let's get a few things out of the way. All of Slack's API requests goes through our edge load balancing tier, which are a set of virtual machines running Envoy. A very simplified way of looking at Envoy config is to consider it's made of mainly 3 components. The first one is listener, which is basically your front end that takes in the requests. Then comes your route, which decides what to do with that request. And then comes the clusters, which are actually backends where the requests are sent to be served. You didn't think it would be that simple. So there's another thing that's called filters. Envoy filters are very, very powerful. And in my opinion, one of the best things that they've done. Filters allows your request to be modified before they are routed to a specific backend. As you can see in the snippets, it's a very minimalistic config. You have a listener, you have a bunch of filter section, then you have routes, and then towards the end, there are clusters. You can have multiple filters, hence it's called a filter chain. And the most important thing here is those filters are executed in the order that you add them. And before I forget, please do not run this thing in its entirety. It's missing the terminal filter. I ran out of space, sorry. Now that we talked about the Envoy config, let's move into the actual architecture. At the edge, we have an API listener at our envoys, which is configured with many filters, one of which is extauth filter, which is a short for external authorization. This filter is responsible for sending the request's header and part of the request body to a gRPC auth service. We're going to talk about the auth service later, but to simplify, when the request comes to Envoy Edge, it takes the request headers and part of request body and sends it to this gRPC auth service. This is what the configuration looks like at the Envoy level. You have the filter, which is extauth. You can specify the name of the cluster that it sends to. You can specify how much of the request body that it's going to send. It's sent in bytes. And then the cluster definition, which is basically how to talk to auth service. We wrote a basic gRPC auth service that implements Envoy's authorization service. Think of this as a protocol that allows both Envoy and auth service to talk to each other, especially in the part that how the request and response will be formatted or presented. If you don't want to read the code on the right, I can simplify it even further. Imagine Bob and Alice wants to talk to each other, and let's assume that they need to establish a set of parameters before they can start communicating. So Alice proposes 1 compliment a day, which are not fine or nice, to which Bob reluctantly agrees, but only on one condition, that there shall be less drama. There is an eye roll involved, but Alice nods. And there you have it. Successful negotiation, and they're ready to start talking. The auth service inspects the request extracts the token or extracts the user information from the token, which in most cases at least, and then that is sent back to Envoy as response headers. The token here is very much Slack client generated. The token embeds the user's secret, but it's not actually given by the user because of trust issues. Or trust, yes. And lastly, the check that is done by auth service is pretty basic. It only checks the shape of the token. It doesn't actually validate. I said a lot of words, so maybe a diagram will make it slightly simpler. Here is a very simplified view of how the overall request flow looks like. User sends a request, which could be sending a message with all the DNS magic in between. The request reaches one of our many AWS NLBs, and NLBs are configured to send the request to Envoy Edge. Like I mentioned, these Envoy edges are configured with ext-auth filter. So when request comes to Envoy Edge, it sends request headers and part of request body to the auth service is as the loop in there. We have this auth service deployed on Kubernetes in all of our edge regions. This is where the token inspection, I say inspection because we're not even validating. This is where the token inspection and user information extraction happens. After which, the auth service sends back the request headers with what it found in the token. The rest of the flow remains unaffected. The web app there is our application monolith. I'm going to be using this term quite a lot for next 10 minutes? I don't know. We'll see. And Envoy www are basically a bunch of Envoy or load balancer in front of web app in the same region because we have only one web app. This is a very, 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 very simplified version of how a request flow looks like within the auth service. Auth service, the first step is when it gets the request, is going to look for a token in an API request. If it found one, then the next step is to check whether or not the token is in the valid format that we expect it to be in. If the shape of the token or format is OK, then the auth service will return a bunch of headers, as you can see, team ID, user ID, and auth result, OK in this case, and return 200. Along with, all these are sent as response headers. If the format was incorrect, it's going to send malformed as the value of all of these headers, but still 200. And if there was no token at all, it's just going to send token not found, but still with the status 200. All of these headers are used for routing purposes. It's a complete different process, which is out of the scope, so I'm not going to talk about those, but they are sent back to Envoy Edge. In addition to that, these headers are also logged as different log fields and sent to our logging pipeline. We use them for debugging purposes quite a lot. As you can see, the auth service will always return OK. With response code 200, we run this in the pass-through mode for now, regardless of whether the token is present or valid. So, we did the rollout in multiple stages, obviously. First, the auth service only checked the request. This was the first phase, where it only checked for the token in request headers. Most commonly authorization header, but it's never that simple. We enabled XODZ filter at our edge, first in our development environment, and then later on to production, one region at a time. It's the usual strategy that we follow for nearly all of our edge either config or any structural changes that we have. After the initial deployment, the user awareness percentage was 20%, was just 20. What do I mean by that? Which means that only 20% of all our API requests had user information. And this is very much from the auth service perspective. That doesn't necessarily mean that only 20% of our, maybe, only 20% of the request had a token in the authorization header. After enabling token lookup in headers, we also enabled parsing of request body for token. Envoy at the edge sent part of request body, not all, obviously, to auth service for token parsing. This brought the user awareness percentage to 50. While there, we also added support in our tooling to actually be aware of the user characteristics like team ID and user ID. This is a completely different tooling which we use to block or rate limit traffic. And prior to this, we could use the basic HTTP parameters like user agent, path, and a bunch of other things to not target, but direct traffic in a different way. So we had to make this tooling aware of user characteristics. Thanks to the pass-through mode that I was talking about, we have had 0 customer impact so far. If auth service is down, we don't really have user information, which is okay, no harm done. It doesn't really impact user in any way, which is nice. Always takes this stress down a little. We started with pass-through mode because we can't really deny requests when we're not actually validating. It just seems wrong when we're just doing basic rudimentary authentication. So at the end of this phase, we were at the user awareness of 50%, which we were happy, but unfortunately, that wasn't enough. It never is. And so it began. Which brings me to the challenges. Every request must have a token, and that request must be present in authorization header. How I wish. For reasons, there is no standardization on where the token is going to be in an API request. Would have been easy or nice. Some clients use the authorization header to present the token. Some clients, and with the clients, I'm talking about Slack clients and SDKs. Some Slack clients present token in the request body. And then there are apps, workflows, webhooks, cache requests, callbacks. The list is long. I can actually go on for a minute. When we started this project, we had to first figure out where all the different Slack clients and SDKs added the token in an API request. We worked with different teams on ensuring that we wanted to standardize to make our lives easier. We can't just keep adding 10,000 edge cases in our code. So we worked with different teams on ensuring that the token was either in the authorization header or, when it was not possible, in the first parameter of request body. But guess what? That wasn't even possible for a lot of them. There were other endpoints which we couldn't really standardize because that meant through going through a very, very long deprecation cycle, for example, third-party apps, because we do have to notify them a very long time before we actually make any changes to that. Which brings me to this. Due to the lack of standardization that I was just talking about, we needed to find a way to get the next endpoint to increase our user awareness percentage past the 50 value that we had before. So how do we pick the next endpoint? Because there is no other way. If you remember a few slides before, I mentioned that we send a header called requests auth result back. And this is the header that we use so much. Like one of the best decisions that we made, it made our journey so much easier, just thinking a little bit forward. Like when you write a software, it is so important to think a bit forward about how you're going to debug issues. You want to make your life easier. You want to add those things that makes your life easier later on. So, thanks to this header that we inject, it was easy for us to see what percentage of total request was OK, malformed, or token not found. And that was our starting point. We looked at, first we targeted, wrong word. First, we looked at all the endpoints or the percentage that was token not found category. So we looked at all the endpoints under token not found and always picked the next biggest endpoint to handle until we got to the point that it was low enough or good enough for us. In the beginning, we also had a really higher percentage of malformed requests. I mean, some were legitimate and some were just, we were not looking at the right place because the token wasn't in the authorization header or in the body. This whole thing was very, very, very iterative and in a way exhausting. We had so many edge cases here to deal with. There were some very hacky decisions, required talking to so many teams. And lastly, and the hardest one for me, was reading hacklang, because our application monolith is hacklang. And if you're wondering, and save you another question, I am really not good at it. And I shouldn't be using word good, but just. So, when we proposed the idea of adding an auth service, an extra hop between our load balancers and backends, one of the concerns from nearly everyone, was latency. Surprise, right? No. But no one knew what an acceptable latency budget was. As a company, we don't have a bucket or upper bound on how much is acceptable, what is just rejected. Since we had no idea how to go about it, and it's not necessarily because this was the first time we were adding an extra hop or considering latency. It's just when you are a growing company, things take precedence and you just deal with the next fire. And this wasn't fiery enough. So as we didn't have any idea how to go about it, we came up with our own budget. Why not? To come up with that, we looked at Envoy logs. Envoy log has this field called duration. This duration field represents the total duration of a request from the start to the last byte out in milliseconds. Based on the value of this field for all our edge requests from everywhere, we were able to come up with a value such that the value that we come up with does not, the faraway regions could just handle it fine because we don't want to increase latency there because they're already slow, and the nearby regions could handle it just fine. And I'm very happy to say that in the end, we were actually able to achieve a less than 5 millisecond latency between auth service and Envoy at P99, which is way, way, way within the limit that we had set in the beginning. Slack has some requests that are very, 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 very big. For example, file uploads. Since our edge envoys send part of the request body to the auth service, we had to decide on how we're going to deal with these requests. I mean, we didn't have luxury to send the entire request body and fish for tokens at the edge due to latency implications. And sorry to disappoint some of you, we ended up making peace with not having user information for some of these requests. There's always going to be trade-offs. There are some battles you win, and some you lose. I'm sorry if I'm a bit emotional on that one. This project was initially developed by 2 teams, shared ownership between demand engineering and sign-in infra. Well, both teams don't exist at the moment, thanks to the power of reorg. Now, shared ownership may sound fancy, I don't know, maybe, but it comes with its own challenges. It's not just about who is working on which feature and how to coordinate changes and bug fixes and what happens when things break, who is responsible. It's more about how to deal with complete silence, motivating everyone, including myself sometimes, that this project is worth picking up despite very little progress. It's about managing expectations, keep advocating for something that you know will make people's life or work life better, and navigating conflicting priorities. Managing all this takes so much of your time and effort, but often goes unnoticed. It's not easy to have a service owned by multiple teams, but it is sometimes inevitable. We had to learn how to operate in this distributed ownership model. Currently, our team, Cloud Network, owns the auth service, but the vision around this service is to do actual validation. And when you start making changes to make it more like our application monolith, it makes less sense for us to own. And we will eventually find another home, but for now, we are giving it a home. So this is where we are right now. After all the whack-a-mole and everything, as of today, we have user information for about 90% of all of Slack's API traffic. This is good enough? I think. If we look at the remaining 10%, most of it is junk. No offense to anyone. Some bots really love us. I mean, we could look at some more endpoints, but that's going to be a lot of tedious work than what it's worth. Besides, we have other pressing matters to deal with. We are currently working on a design for implementing token validation. Since we only do shape checking, the next step is validation, because we want to reject any unauthenticated or invalid traffic right at the edge, and we don't want it to go further down the layer and consume resources. We don't want to. The very long-term plan is to completely move authentication from the application over to the edge. I know it's scary. A lot of people are going to get a lot of anxiety. But, well, token validation is the first step towards that. Once we have the validation, we will be able to compare with our monolith on whether or not we're doing things right. We can detect any regressions or maybe improvements along the way. You never know. This is the timeline of the project so far. It's been a long road for some of us. We started proof of concepts in late 2021. Initial development was done in 2022. One thing to note here is a lot of this work was done outside of the quarterly project work, either due to conflicting priorities or not enough staffing. And you can see the 2024 was by far the most busiest and the significant one in terms of the progress. Right. Oh my God, I don't have much time. What did we get out of all this? I'm going to try to run through this quickly because I want to make sure that we have time for questions. Now that the requests are tagged with user information, even for webhooks and bot requests, we are in a better position to identify where the traffic is coming from, at least for the majority of them. In the past, we have had events where certain bot or webhook or a certain resource-extensive APIs were getting a lot of requests for. And now we can rate limit a specific bot or webhook. We can also rate limit unauthenticated traffic, which is by far the most popular one for us. We have a rule set all the time for unauthenticated traffic. We can tune how much, but this is the most used for us. With this, we also have the ability to make routing decisions based on user information. This is useful if we want to introduce certain features to certain customers or things along that line. And lastly, this has enabled us to route suspected traffic to our low priority cluster, which we call as quarantine cluster, where these requests will not affect the rest of the users. It's a great level of isolation that we didn't have before, and this project enabled us to do. Troubleshooting. I didn't mention this before, but all of these user IDs and team IDs are all anonymized. When you look at them, I think the example, you can't really know which company, workspace, and blah, blah, blah. You do have to do some processing if you want to know. And we have used these anonymized IDs in so many incidents because they help us understand the traffic pattern during the incident, which anything that simplifies your life during an incident and reduces stress is welcomed. And this is that for us. We can narrow down the spikes in the traffic down to a workspace or a user or a bot, and that's just marvelous. In the beginning, I talked about we had multiple events where some of the resource-extensive APIs were particularly hit, causing customer impact. Those set of incidents are completely eliminated. I cannot give you numbers, but they are big enough that we actually had to care about them. Yeah, that's it. Right, I still have a bit of time. Okay. X.z plus the auth service plumbing can be used to turbocharge your edge load balancing and load management. It really, really works, and we have tested that at scale. Increased visibility into where your traffic is coming from unlocks a lot of capabilities, not just in regular operations, but in incidents and troubleshooting. Goes without saying, standardize where you can. It really helps. It will save you a lot of trouble, especially if you have public-facing APIs. The more distinct authentication methods you have, the harder it is to implement something like this. And it gets even harder if you don't know how many you have, because you won't know what you've missed. I'm going to let that sink in for 2 seconds while I transition. Embrace the edge cases. They spice up our lives and make us smart. Have you ever heard anyone say that, oh, I had to deal with a lot of edge cases and I learned nothing? No, the answer is no. Absolutely not. Thank you.